Hello and welcome to section 2.5, the fundamental theorem of algebra. And basically what we're talking about for the fundamental theorem of algebra is if we're given a polynomial, the highest degree of this polynomial will have that many factors as have that many zeros or factors for this. And a linear factor is basically writing a factor as an equation of a line. So like x plus 2 is a linear factor because it would mean that x equals negative 2 as a solution. We can have linear factors that are, so for example, if I took a polynomial, that would be, I'm just going to use something, x squared plus 2x plus 1. Now if I factor this, I would get x plus 1 times x plus 1. So these guys are the linear factors because they're equations of lines, and they're multiplied together, they get me back to my polynomial that I started with. And so that are the linear factors. One thing you got to worry about is that we could have imaginary solutions that would be linear factors, and we'll talk about writing those as the imaginary solutions as linear factors also. So for example, if 4i was a linear factor, then I would say x minus 4 would be one of my solutions, and we'll talk about the other part as a linear factor also in just a matter of moments. So then, to find all the zeros of this, so when we're talking about the fundamental theorem of algebra says that there are going to be 3 solutions. That doesn't mean that all of them are going to be real solutions. It just means that there are 3 places where we have solutions to this. So some of them might be imaginary, some of them might be real. So if my function is f of x equals x cubed plus 4x, you might want to graph this to see what the graph looks like. If I was to solve this for zeros, I would factor out an x and get x squared plus 4. Now, I can use my zero product property that says x will equal 0 and x squared plus 4 equals 0. You may be asking, why didn't I factor x squared plus 4? Remember that this is a non-factorable situation. We have to, because it's plus 4. If it was minus 4, we could factor it. But I'm just going to solve these algebraically, and so x equals 0 is one real solution. Over here, x squared will equal negative 4, so if I take the square root of both sides, x will equal plus or minus the square root of negative 4. Now remember, from the past, if we're taking a square root of a negative number, we're going to end up with an imaginary root where x will equal plus or minus 2i. And so that was from the fact that the square root of negative 4 is the same as the square root of negative 1 times 4. It's the same as the square root of negative 1 times the square root of 4. The square root of negative 1 is I, and the square root of 4 is 2. So I end up with that as my solution. And the plus minus comes from the fact that I have 2, that I took the square root. So writing these guys, these are my zeros. And my solutions, if I wanted to write them as linear factors, I would say x would be a linear factor, that's a line. Another factor would be x plus 2i, and the final one would be x minus 2i. So as a group of linear factors for this, you will end up with something that looks like this. You will notice that in the imaginary I have 2 solutions. They are conjugates of each other, and that will always happen. If you have an imaginary root, you will always have its conjugate. And so if I want to find the zeros of this function, I would probably go ahead, I should probably go back and graph this guy. And if I was to graph this, you'll see that it only crosses at 0. So let me get a graph here and get rid of all this. If I graph this guy, I get x raised to the 3rd plus 4x. You can see that when I graph this function, it only crosses at 0, 0. So that's really what I'm looking for when I go ahead and graph this. That's this x equals 0. And so this is writing the function as a group of linear factors. These are my zeros of my function that I have in the boxes. And so to answer the question, were these guys in the boxes. But as an extra added bonus, you get what the linear factors are also. So then for something like this, if we want to find the zeros of the function and you don't have any place to start, I would probably go to graph the thing and see what happens here. Hopefully we'll get a factor that crosses the x-axis. Plus 2x squared minus 12x plus 8. And so when I graph this, you can see that I get a bunch of solutions. I'm not going to zoom out. It goes up and comes back down. But you can see I have different solutions. And so I would probably use like long division or synthetic division or something to find that those values. And you'll notice that it comes down and touches here. I probably will have two factors that are identical in there. So I'm going to use, looks like -2. So x will equal -2 as one of my solutions. And so I'm going to go through, and I'm going to use synthetic division in this just because it's a little bit quicker. I have x to the 5th as a leading coefficient of 1, x to the 4th is 0, x cubed is 1, x squared is 2, the coefficients -12 and 8. And if I get a remainder of 0, then -2 is a factor of this. So bring down my 1, multiply by -2, add straight down, 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 multiply by -2, and get a remainder of 0. So now x equals -2 is a 0, or a linear factor would be x plus 2 for that guy. And so now I have this great function of x to the 4th minus 2x cubed plus 5x squared minus 8x plus 4, and then I'll have to probably pick another 0, and it looks like maybe +1 would be another one. So I would do synthetic division on that and say, oh, -1, and see if I can get that be another 0. So -1, and I still have my leading coefficients of 1, -2, 5, -8, and 4. And so I will try synthetic division on that. And so bring down my first term, 1, multiply by -1, add straight down, multiply by -1, add straight down, multiply by -1, which is -8, -16, multiply by -1, and I get 16, and so I get a remainder of, looks like 20. So this x equals -1 is not a solution, which I could see. Maybe I should have tried +1, and that might have worked a little bit better. So let's change that to +1 and scrap this whole thing and see if we can try it again. And this was a -2. So if I add straight down, I get 1 times +1, add straight down, I get -1, -1 over here, add straight down is 4, multiply by 1, I get 4, that's -4, multiply by -1, and it looks like 0. So I chose the wrong one. It looks like +1 is my other solution, so x equals 1, or x minus 1 is another solution. These are my linear factors. I'll put the linear factors in parentheses. And so now this guy down here is my next one, which would be x, let's see, where am I at here? I went down by a power, so that's got to be cubed, minus that's x cubed minus x squared plus 4x minus 4. And now looking at this, I'm guessing +1, since it comes down and touches, is another solution. So I'm going to try again +1 and use this. And so you can kind of see how this is going to find all my factors. Since I can't factor this guy, I don't know how to factor that. I'm going to bring down my 1, multiply by 1, 0. I get 0 here, add straight down, multiply by 1, I get 4. So now I'm left with another one of x equals 1 as a solution. So another factor, a linear factor, is x minus 1. And I'm left with this thing of x squared plus 4. Now x squared plus 4 from this, because I'm missing my x term, basically means that no matter what, I'm going to get an imaginary solution because we did this in the last problem. And so that means I've got x squared equals -4. And so then x is either plus or minus 2i, because I take the square root of both sides, and remember plus minus, and so that's what I get. So my solution over here would be x equals 2i and x equals -2i, and as linear factors would be x minus 2i for the top one and x plus 2i as the bottom one. So way back at the beginning here, if I take all my parentheses and put them together, I would have my factors of x, what was it? I got to go back, I can't remember. X plus 2, x minus 1, there's 2 of them, so I squared it, and then x minus 2i, x plus 2i are my linear factors of the original function. Now, solutions are all the ones that I put x equals to, and so solutions are x equals negative 2, positive 1, I don't have to write it twice, and 2i and negative 2i for this. I don't have to write, there's a multiplicity of 2 for this guy, and so I don't have to write it twice. So that would be all the solutions, all the zeros, and as an added bonus in the green here would be the linear factors of that original function. If you have any, I still have complex conjugates to talk about, and that kind of led into when we had the solution of x squared plus 4 equals 0. Well, that would be x squared equals negative 4, and so x comes out to be plus or minus 2i when I take the square root of both sides. Well, these guys, 2i and negative 2i, are complex conjugates of each other, just like if you have 4i, its complex conjugate is going to be negative 4i. And anytime you have an imaginary 0, you will have its conjugate as that 0 also. So what is the conjugate of 5 minus 2i? That would be 5 plus 2i. And what is the conjugate of negative 3 plus i? That would be negative 3 minus I. And so these guys would be solutions to the problem as we're going through. And we'll talk more about this stuff when we come to class. If you have any questions, please feel free to come and ask, and we'll talk about it.